In this video, we're going to go over how to do some gram to mole and then to particle conversions. So first, here's this flow chart that we use for doing mole conversions. And you'll notice right away that this over here shows the given and desired. And then the C stands for conversions. So this is given, and then this is desired. And then this C right here stands for conversion factor. So what you have to do is try to figure out what unit you're given in one of these problems, what you're trying to get to, and then this right here, this piece right here, tells you how to get there. So this is like the last thing to try to fill in. So let me give you like a real basic example. So let's say you have 40 grams of water. 40.0 grams of H2O. Okay, and you want to figure out how many molecules of water that is. So you want to know how many molecules of water. Okay, so your given unit is grams, and this is important too. You have to write the substance. So you're actually starting right here. You're given mass. That's where you're starting. And the question is asking about how many molecules that is in the question. So you have to try to convert it to this right here, to number of molecules, okay, from starting with grams. Okay, so this problem is going to take two conversion steps to get there. So you have to get to moles first, and then you can get to molecules after that. Okay, and to get there, to cross these bridges, you need to use, for the first step, the molar mass, and then for the second step, you're going to use Avogadro's number for the second step. So when we first start doing these, I always have my students begin doing these by writing everything out in these GCD tables. So just to keep track of all the information. So the first thing to write is your given. So this is the first thing to write is 40.0 grams of H2O. Your desired is you're trying to figure out how many molecules that is. Be careful when you abbreviate. You should write at least molic if you want to abbreviate for molecules so you don't mix it up with moles. Now the next thing to do, so that's the second thing to do. The next thing to do is to figure out how to get there. So again, we're starting at this red star, which is grams, and we're trying to get to the green star here, which is molecules. So our first thing, the first conversion factor is this. Okay, and as you see this arrow pointing here, it says that's the molar mass on the periodic table. Okay, so I'm gonna in order to get from mass to moles, I need to write down the molar mass. So I'm gonna write 1 mole of H2O is equal to, basically, actually all I'm doing right now is copying that into my first conversion factor. Okay, and then H2O is one. Sorry, it's 2 H's and 1 oxygen. So if we pop that in our calculator, we'll get 18.02 grams of H2O. That will take us to this middle part, the mole. Okay, but now we have to do one more. So I'm going to erase that. So the next thing that we're going to do is Avogadro's number. Okay, depending on what substance it is, Avogadro's number could be an atom unit. It could be a molecule, or it could be a formula unit. So if this were just like oxygen, then our unit would be atoms. But in this case, we have a covalent molecule. If it were a formula unit, it might be NaCl or something ionic. Okay, so Avogadro's number, the units can change. It depends on the problem, what substance it is. Okay, so the next conversion factor is going to be Avogadro's number. So 1 mole of anything, it says 1 mole of X. In this case, X is H2O. So 1 mole of H2O is 6.02 times 10 to the 23rd molecules. Okay, and now I'm ready to solve. So next, I'm going to rewrite my given 40 grams of H2O times. You could put this over 1 to make sure that you have the numerator and denominator separated. So we have 40 grams of H2O. So I want to put this grams of H2O, I want to put that right here so that it lines up. Okay, so I'm going to take this 18.02 grams and write it there of H2O. Okay, and then the other half of the conversion factor, 1 mole of H2O goes on top. Okay, times. So our grams of H2O cancel. Now we need to do something about this mole of H2O. So for that, I'm going to use the next conversion factor. So I'm going to write 1 mole of H2O on the bottom so that it cancels. And then the other half of it goes on top, 6.02 times 10 to the 23rd molecules. Okay, and so using this flowchart, we were able to answer this question: how many molecules are in 40 grams of water? Okay, so I can take out my. Remember to these are kind of like the ways I recommend solving this on your calculator. So you can we enter our 40 grams times. And the way I like to, so I always enter all the stuff on the top in the numerator. Actually, I should probably put it all in parentheses on the top. Okay, and for Avogadro's number, I usually enter it like this, 6.02, and then I use this E button here, and I type 23 like that. Close the parentheses, then hit divide, and then now I enter the 18.02 on the bottom and enter. Okay, so this E means times 10 to the 24th. Usually just keep 2 decimal places. It actually depends on sig figs. But you know, in general chem, I don't really look at sig figs unless I specifically ask. So we're just going to keep 2 sig figs and round it off at that second 3. So 1.34, and don't forget this part, the times 10 to the 24th. So 1.34 times 10 to the 24th molecules of water are in 40 grams of water. Okay, so that's actually, in terms of moles, 1 mole of water is 18.02 grams. So if I have 40 grams of water, that's going to be a little over 2 moles, or 2 times Avogadro's number, as you can see here. Okay, so that's a little bit over 2. All right, so let's try a couple more practice ones. Okay, so here's a practice one. So you may know on this conversion flowchart, okay, it really depends on the problem. So that's like no 2 are going to be the same, but this flowchart is made to be generic to fit any type of these conversion problems. So notice, like, you may start here on these problems. You may start way over here. You may start right here at the mole, and then you have to go here for your desired. Okay, so it just totally depends on how this asks, right? So it's very similar to, like, if I ran like 10 kilometers, then how many miles is that? Okay, someone could just as easily ask, well, what if I run a marathon, which is like 26 miles? Then how many kilometers is that? Okay, so it just depends on the nature of the question, like where you're starting on this flowchart, and then where you're ending up. Okay, so let's figure this one out. So I believe I have a GCD table set up here. Okay, so how many moles of 30 grams? So that's my given, 30.0 grams of carbon dioxide. So I need to write out carbon dioxide. And my desired is how many, this is my question part. So this is my desired here is how many moles of carbon dioxide is that? Okay, so the next thing to do is figure out where we are on our conversion. So figure out where you are on here and then where you're going. So we're actually starting here at grams. So we have 30.0 grams, and we're trying to go here to the mole. So this problem is only going to take one step. It's just a molar mass step. That's it. Okay, so I'm going to take that and I'm going to copy the molar mass right here. Instead of X, I'm going to write CO2. Okay, I put X here to make this flowchart work for anything. So 1 mole of CO2 equals, so I add 1 carbon and 2 oxygens. So 1 carbon is 12.01 plus 2 oxygens, 2 times 16.00. Okay, and then that should give me 44.0 grams of CO2. Okay, and now I'm ready to solve. So I rewrite my given. times, I make a line. I have my gram unit is right here, so I put 44.0 grams of CO2 here and 1 mole of CO2 on top. So grams cancels, and then I have 30 divided by 44. Okay, and I get 0.68 moles of CO2. Okay, so let's do one more example. Okay, example 2. How many molecules are in 2.4 grams of N2? So here's my trusty flowchart. It covered up my desired here. Okay, so first things first, let's get our given, our desired, and then we'll figure out where we are on the flowchart. So 2.4 grams. So 2.4 grams of N2, and our desired is how many molecules is that? How many molecules of N2 is that? So starting here at the mass, so I have 2.4 grams of N2, and I'm trying to figure out how many molecules that is. So I'm trying to go over here. So this problem is going to take 2 steps. So the first thing I'll do is write down the molar mass. 1 mole of N2 is, so 1 nitrogen is 14.01, so 2 of them would be 28.02 grams of N2. Next is, so that takes me to the mole, and I need to go over to molecules, so I'm going to use Avogadro's number next. So I'm going to copy this into my next conversion factor. So 1 mole of N2. This is similar to the first example I did when I first had that the flowchart on there. 6.02 times 10 to the 23rd molecules of N2. Okay, now I'm ready to solve. So rewrite my given times, make a line. So I have grams. I need that to go away. So here's my number and unit that has grams in it. So I'm going to put that here, 28.02 grams of N2. 1 mole of N2 on top, grams cancel. And now I'm left with moles up here. I needed to say molecules. So I'm going to write this term down. Looks like it's pointing to the numerator. So I want to write here in the denominator, 1 mole of N2 here. And the other half of the term goes up here, 6.02 times 10 to the 23rd molecules. Notice I'm solving for something super small, so I should have like a huge number here. So 2.4 times 6.02. And I get 5.16 times 10 to the 22nd molecules of N2 for my answer. Okay, I'm going to do one more example, and then I have 2 practice ones for you to try after this. So here's my last example that I'll do is actually these are all looking like pretty similar. I'm gonna not do this example. It's actually really similar to the one I just did. Very similar. So I'm gonna go straight to the ones for you guys to try. Okay, so the first one is this one. So it says your turn, number 1. Okay, so you could pause it and then copy down this problem in your notebooks and then try this problem. So I'll give you a second to pause. Okay, go ahead and pause it. Okay. Okay. And here's the next your turn. Here's the next practice problem. So let me give you a hint on this one. Notice on this one that you are starting way over here this time, which is different than the other ones, the practice ones that I've been doing. So you're starting right here. That's your given. And your desired is how many grams. So your desired is right here. So this is where you're going. So this is your first step on this one. And then this is your second step on this one. So you should notice that your compared to the example that I did, your conversion factors are going to be flipped, basically, because you're going like the opposite direction. This is kind of like what I was saying before, is like if I run 10 kilometers, how many miles is that? This problem is kind of asking, like, if I have 26 miles, how many kilometers is that? So you'll notice your conversion factor is the same, it just gets flipped when you convert from one to the other unit like that. Okay, so give these two your turn problems a try and we'll see what you come up with tomorrow in class.